Okay, so like I said, miscellaneous trigs. A few more like kind of things you want to hit. Bless you. All right. So one big thing I want to make sure we're still good with would be those identities. Okay, we should still be kind of comfortable, you know, simplifying some trigs, which is bless you. Okay. So for example, we should know that tangent of theta is equal to 1 over cotangent. But I'm actually looking, sorry, in terms of sine and cosine, how can we write tangent?
Oh, isn't it like sine over cosine?
Yes, that's right, Austin. It's sine of theta over cosine of theta. Okay, sine of theta divided by cosine of theta is the same thing as just tangent of that same theta. Okay? So if that's true, if tangent of theta is equal to sine of theta over cosine of theta, and also that tangent of theta, or cotangent of theta is 1 over, right, so then what must cotangent be? If tangent of theta is sine of theta over cosine theta, cotangent of theta must be what? Cosine theta over sine theta, right? And it makes sense because we know that cotangent is just the reciprocal of tangent, and so the reciprocal of sine over cosine is cosine over sine. So they should be just the same thing there, just reversed. Okay. Again, if you're afraid, you know, for me, I like to try and come up with little ways to help me remember things. That way, I don't have to to remember things easily without having to really memorize. And so cotangent of theta is equal to cosine of theta over sine of theta. So cotangent is cosine over sine, tangent is sine over cosine. So that kind of helps me remember there. The co and the co, they do go together there. That's right, co-co. All right, let's see here. Some other identities that we need to be familiar with. These are called the Pythagorean identities. Not that you really need to know the name, but there they are. Okay. Sine squared theta plus cosine squared theta is equal to 1. It's the same thing as 1. Okay. You'll remember there are 3 of these. Okay, but if you can remember this first one, then you don't need to really worry about memorizing the other 2, because you can get the other 2 using just this one. Okay, and the way we get the other 2 using this is we take turns dividing by sine squared on each side, and that gives us the other one, or another one, and then we take turns dividing by cosine squared on each side, and that also gives us the third one then. Okay, so let's take turns here. Let's divide both sides by sine squared first. Okay, so if I divide both sides by sine squared, what's sine squared divided by sine squared? 1, okay. Cosine squared over sine squared, what does that simplify to? What's cosine over sine? We just said it. It's cotangent, so cotangent squared is what we get then, because we're dividing by sine squared. Okay? And then what about 1 divided by sine squared? What's that the same as? Cosecant. Yep, cosecant squared. So there's another Pythagorean identity. Okay? And then by similar fashion, we'll get the third one. So now let's divide this sine squared plus cosine squared equals 1. Let's divide that through by cosine squared. So sine squared divided by cosine squared is going to yield what? Tangent squared. Okay? And cosine squared divided by cosine squared is just going to be 1. And then 1 over cosine squared is secant. Just secant squared of theta. Okay, so there are the 3. So if you can remember that first one, that's going to be huge. You can then get the other 2 if you really need them. Okay? And of course, you can manipulate these around. So, for example, this thing is the same as, we could say like sine squared theta is equal to 1 minus cosine squared, right, theta, right? If I just subtract cosine squared from both sides, then I have this. So you can kind of manipulate those around if you need to match whatever you've got. Okay? There are more of these on page A42, but we're really just going to worry about, I think these are the ones that are the most important ones. I don't think there's anything else that's like super important. Like you don't need to worry about like double angles or anything like that. Okay? So, alrighty. So let's also talk about solving triangles using trig. Okay. So let's see here. So as an example, okay, so our directions here are to solve for x. Okay, so let me draw a triangle here. All right, and we got a right triangle, we'll make that. I'll put x here for the hypotenuse, and a 15 there for one side, and then we'll call this angle there 42 degrees. Okay. So how? Question.
No, I was gonna. No,
Okay. So my question is, how can we set this up? How can we solve this? So Ryan,
isn't it like side A over angle A?
So go ahead. Keep.
So,
I mean, give me
like,
in terms of the numbers here. What would we do?
So it would be. I think it would be 15 over 42 or 42 over 15.
Okay. 15 over 42, like that.
Yeah.
So just 15 over 42 degrees.
Yeah. Or plus.
I think sine of 42 is what maybe you were thinking there. Yeah, 15 over sine of 42.
Angles over the.
Yeah, that's right. 15 over sine of 42 must equal what?
Must equal would be x equals over the sine of 90.
Over the sine of 90. Yeah. Okay, that's one way to do it. What is this that we're using here?
Law of sines.
Law of sine. Law of sines. That's right. So you could use law of sines. Absolutely. And so let's see here. So make sure your calculators are set in this case. Okay, I know I said a calculus commandment was that we always calculate in radians, but because this problem is given to us in degrees, we're gonna stick to the degrees. But whenever you're asked to find an angle, you need to put it into radians. Okay, so right here it's already degrees, so we're gonna keep it in degrees. Okay. So oops, I gotta check my mode here. So my mode is currently set to radians, so I have to arrow over and change it to degrees. Okay, and so then let's do this. So let's see here. Sine of 90, well, we knew that. I should have known that, right? It's 1, so it's x over 1. And then 15 divided by sine of 42. And again, guys, when I do stuff in a calculator, you should really be doing it in your calculator as well, okay? I know some of you are like, oh, I hate using the calculator and I don't want to practice and stuff like that, but it's going to be important for you to practice this, just make sure you're able to type things in correctly. Okay, if you're not typing them correctly, you are going to be in trouble on the test. Okay? So don't not have a graphing calculator handy. Not have a graphing. Did you use one of that? I changed it to degrees for you. So again, type it in. Make sure that you know what you're doing here. Make sure you can do it right. So I got 22.417. Ugh, my handwriting's terrible there, but you get the idea. Okay. So the answer would be 22.417 degrees, right?
No. Side length. So it just be units.
Oh, right. Yes, it's just units.
And if there's no unit given to us, just leave it.
You can just leave it. You don't have to put a letter U or anything like that. It's okay to just leave it. But yes, if there are units, please abide and label by them, okay? And the reason for that is because oftentimes, even if you have the wrong number in a pre-response question, okay, on the AP test, oftentimes you get a point for just having correct units. Even if your number is completely off, you can get a point just for having correct units. So make sure we really do abide and understand, what the units are and label it correctly. Okay, now, that was one way to do this, but there's actually another way to do this that you, okay.
Ask your boss if you could do it that way.
Okay, so Brandon, what's the other way to set this up?
You could set it up using, I guess, the sine of x
Yeah, you would say sine of 42
is equal to 15 over x.
16 over x. Yeah, believe it or not, guys, this is the way you used to do it back in geometry, okay? When you first learned sine, cosine, and tangent, this is how you would solve for missing parts of a right triangle. Now, why is law of sines, better, not better in this case, I guess I should say, but why is it like better useful overall? Why is it more useful overall? Sorry? Okay, yep, use it for more different things, that's true. Doesn't have to be a right triangle, that's right. Is that what you said, Emma? Yeah, it does not have to be a right triangle, which is really nice, right? To use what Brandon did, so this kind of ratio, these ratios are only true for right triangles, but law of sines is true in general. And so that's why it's all, like you said, Tyler, it's more generally useful. Yep. Okay, so again, just real quick here, I'll go ahead and do that one too this way, just so you can see it. So sine of 42, we said was 0.669. And that's 15 over x, and then I'll multiply the x over, and then divide both sides by 0.669. And we get x equals 22.422, I guess I'll say. But you can see how much they differ, right? The tenths are the same, but the hundredths and the thousandths are different because we rounded that 0.669.
So on an AP test, would they be ready to see a difference in answer?
So I believe if you show that you rounded here, then I think it's okay to carry that kind of through. Yeah, I think it's okay to kind of, as long as you're showing your work, I think you should be okay. Yes, I think you should be okay. You know, try to stay as precise as you can, though. Is really what I would say. So if you can just keep it as sine of 42, like if you can manipulate this, something like this. If you can say, all right, this is going to be x times sine of 42 equals 15, and then just divide both sides by sine of 42, so you get 15 over sine of 42, and then, you do x is approximately equal to, and then you can, actually just do it this way, then you'll have the precise answer.
Yeah, I usually, when I do it, I'll say that I rounded to 0.669, but I'll actually keep it in my calculator,
That's exactly. So what I'd recommend you do then, in that case, is I would leave it as sine of 42 until you then do the final calculation and then give me the 22.417. Right. Because again, that's confusing because you're saying one thing but you're actually using a different thing. Yeah. So, all right.
I learned that from science classes.
I got you. Yeah, exactly. And I know this is the way the AP test is, and different people do it different ways. But yeah. All right. Next one we're going to solve for theta here. Theta now is what we want to solve for. That means we're solving for an angle. Okay, so give ourselves the right angle there. I'll put theta here. It's not exactly drawn to scale, but should be good. Can we use law of sines here? We could, actually, okay? Because we can find this third side, can't we?
Yeah.
Using the Pythagorean theorem, and then we would have a side and an opposite angle, and then we'd have 28 over sine of that. But that would require more work, so we probably don't want to do law of sines here. It requires a little bit more work. What should we use instead here? So we could use law of cosines, I think.
Or just use
maybe
sine of theta equals that.
So yeah, we don't use sine. Don't use cosine either.
Okay.
Yeah, so let's look here. Look what we have. We have theta, and what do we have? What's this? This is the opposite leg, and this is the adjacent leg. So we want to use tangent, right? Tangent. That's the TOA part of SOHCAHTOA. So we'll say tangent of theta, that's our unknown. Tangent of theta is equal to opposite 28 over adjacent 17. Okay. Now how do we solve this? What do we do with our calculators to solve for theta here, to get theta by itself? Do we divide both sides by tangent?
No.
No, what do we do here, Ben? Yes, inverse. So in our calculators, because we don't know, 28 over 17 is not a ratio that we know. So this is something we have to use our calculators for. We do not have on our unit circle a ratio of 28 over 17, right? We know root 3 over 2. we would know, 1, we would know 1/2, something like that, but we can't necessarily do that. So we have to do second tangent, and then 28 over 17. Okay, so 58.736 degrees. Okay. And again, I know, calculus commandment, we calculate in ratings, but it's okay to be in degrees for right here. Okay. All right. By the way, could we have used the Pythagorean theorem up here to solve for this missing side?
No.
Why not? We only have one side. We don't know this other third side. So when we can't use Pythagorean theorem, right, when we only know one side of the triangle to find another side. But here we could have used Pythagorean theorem to find that missing side if we had wanted to. Don't need to, though. All right, I'm going to give you 2 to try. The first one is going to be pretty straightforward. The second one is going to be a bit of a challenge, but I want you to, give it a shot. Again, part of the goal here, okay, I like to try and, not only show you not always show you everything you need to learn. I mean, you have all the skills to do this second one. You have all the skills. So anyway, all right, let me just stop talking first. I'll write it down. So we're going to, first one, solve the triangle. It's very straightforward. Okay, so you know what I mean by solve the triangle, right? Is to find all the missing angles and all the missing sides. Okay. Okay. And then, actually, you know what? We'll hold off on that. I'll just give you this one. Let's try that. I'll just give you this one. So right now, we'll try this one, and then we'll get together and we'll do that. And after you solve the triangle, I want you to find the area and perimeter. Okay? So once you solve the triangle, I want you to find the area of that triangle and the perimeter of that triangle. I guess I better do it too. Well, the third decimal place is going to be not a 9, though, so you get 49.995, right?
I got 49.996.
996. Okay. Remember, 3 decimal places is our standard, so. Well, so even with rounding, it wouldn't round up to 50. If it was 3 decimal places that we're trying to keep, it would not round up, right? Exactly. Okay, I got. Yeah. Well, no, but again, if we're trying to keep 3 decimal places, it should say 3.996. We should round to that 3rd decimal place, which would be 6 still. So you want to round.
So perimeter and area as well.
Yep. Please find the perimeter and area as well. Okay. What's your area right there? Oh, that's angle A. Yeah, I want to find the area. That's right. Find the area as well too. Sorry. So perimeter's good, but also find the area too. Yeah. Find the area and perimeter. What do you think? Did you do? I think. Okay, be careful. 9 is the leg of the right triangle. 14 is the hypotenuse. Yeah, you have to fix those answers.
I feel like I goofed. Yeah, it's not pretty good.
Like the size, I got like square root of 115 is like 10.724.
Yeah.
Womp womp.
Okay, those are pretty good.
Yours match up there with Christian's?
My 7
Triangle? Nope. You want a circle? Those circles. Yeah. Right, because how do you do that? What are you doing when you're making this, like, it's like, you take this triangle and you, like, copy it and you make a rectangle from it. And so if it was base times height, that'd be the rectangle, but you want half of that because it's 2 triangles. So, yeah. Just check this one. Good. Hey, how you doing back there, buddy? All right. That would be the depth. You can round that again. You like to abide by the whole like 5 thing. Yeah. Like, screw it, man. Man's not gonna tell me that. He's right. Sideways. That's true. That's a good thought. I never thought about that. Yeah. It bothers me too. Spiral notebooks. Okay. Let's take a look here and see how we did. So, We should have gotten a square root of 115 there for that missing side, yeah. Okay, angle A, 49.995. Angle C, 40.005. And then for the area and perimeter, whoops, I don't think I actually put those up there. So the area then is going to be 1/2 base times height, okay? So which side can we call the base? The 10.723 or the 9, but definitely not the 14. Okay, remember, base, we have to like kind of move away from the idea that the base is always the bottom of the shape. That's not true, right? The base and the height, when you're talking about a shape, they must be perpendicular. So that would be this measure and this measure. It doesn't matter which one you call the base, which one you call the height. So it's 1/2 times base times the height. So 1/2, 9 times the square root of 115. So that's going to be approximately 48.257. Okay, 48.257.
What are you doing with the square?
Well, because there was the side was precisely square root of 115 from the Pythagorean theorem. But then people rounded it probably to 10.273. Okay, and then perimeter, okay, is exactly 9 plus 14 plus the square root of 115, to which is an acceptable answer. You could have stopped right there. Okay, and a free response question, for example, on the AP test. Okay, for a free response question on the AP test, if you get down to an answer and all that is left is arithmetic, you do not need to add the 9 and the 14 together. You don't need to. You can stop and say, there's my final answer. Okay? And that, well, they will then, calculate it out to make sure you got it right or something like that. But if your answer in working out your calculus, you then get down to like arithmetic and that's all it is, then you don't need to simplify any further. You're done. You may circle that as your final answer. It's kind of nice. But I'm going to do it just because it's approximately, what did I get there? 33.724. And that's really nice because what if you accidentally make a mistake in your arithmetic, or maybe you misround something? Well, guess what? They'll take a point off for that. Okay, you'll lose points for that. But if you just leave the arithmetic for them to do, which you're allowed to, they won't take points off. Okay,
so that's
kind of nice.
I didn't use the Pythagorean theorem. I used the
law of sign. Okay, which is. Yeah, that's right. You didn't get a square root. Yeah. All right. Let's do one more here. I'm going to have you guys tackle this one as well. So, and this one we can do actually no We're going to do this no calculator. Send calculator. Okay. So no calculator. Okay. This is like challenge accepted here, right? So find the area perimeter. Area/perimeter, and this is a bit of a challenge one, but again, I think we know you guys, each one of you, individually, has the ability to do this, has the knowledge, and has seen this before, so there's nothing like crazy here, it's just going to be a little bit of a challenge. Okay, so let me start out here by drawing this part. It's the easier of the two, I think. Okay. Be very careful how I draw this. I'm putting a dotted line here. So you can see the shape ABCD. ABCD is going to be actually ABCD has 4 sides, so it's actually a quadrilateral, but it is made up of 2 triangles kind of put together there. Okay, I'm going to give you some information. So I put this little dotted line there on purpose. Okay, I'm going to zoom in here too some. So there's that, and I think, oh yeah, I need to give you this and that. And this dotted line has a length of 1. And so, yes, I think you should have enough information to figure it out with a calculator. That's right! Just your brain. I heard that cover coming off. Brandon's trying to be sneaky. Just kidding. I know you're not. All right. So yeah, find the area of that area and perimeter of that shape. If you get stuck on one, maybe you're like, I don't even know how to do the area. Try the perimeter. Try the perimeter at least. Okay. If you have no idea about the perimeter, try the area. If you have no idea about anything. Well, you can put your hand in the air and just might come around. You can talk to people around you, okay? My recommendation, though, try to come up with the angles okay, to help you out, and then try maybe help you figure out the size and stuff. But actually, you know all of this. If you would like, let me know, and I will get you snacks.
They're all over.
Candy, or you don't want to
Too.
what you would like for me to talk for you. Well, thank you for helping me. I like to,
Yeah, I think we do that. Hey, that's, you can do the right thing. Is it all over?
yes. Just going to see some things.
Yeah, I'm sure
But leave it like this.
We're not going to use. We don't need to use law signs. So you could use it if you wanted to. I guess so. That would work. You could do it that way too. Actually, I shouldn't have told you on that. You could use law signs if you really wanted to.
I just want to get a lot of the like in last year, and we need to make sure that you would do like the sign with like
That shouldn't be. Now, either you could have done it with both signs, like signs on top, the number, the size on the bottom. That's okay, but you would never, it would not flip flop like that. Yeah. No, that would be true. Well, so you, like I said, you could do it the other way. You could have the signs on top and the sides on the bottom. That would make sense.
is this just like this is opposite over?
No, for log signs, it's really just the side of the angle over with the side, with the opposite side there. So here it's like sine of 42 over 15, or 15 over the sine of 42.
Is it cosine?
No, cosine, the log cosine is a different,
That's the equation.
yeah, so we're crazy equation, but you don't have to worry about it. We're not going to use that in this class. Okay. But you can use log signs if you really want to. I'm sorry, I should not have told you to erase that. Okay. Questions? Anyone stuck completely in it? Okay. All right. So I mean, so you got the little congruency marks. So what does that mean? Those two angles have to be. Okay. But more specifically, what's the value? Yeah. They're both well, they're going to be 45 because of a triangle, right? And that's... Oh, okay. Okay, so that's helpful, right? All right. So, if you have... Here, break this down. We have two triangles, right? We have a 45, 45, 90 triangle. The hypotenuse is 1. What does that mean each side must be? Remember, like, the relationships and stuff like that.
I don't know what yours was.
Okay, so we're going to do that. Okay, we're going to do that. Let's just call this side X. We don't know that side, right? Okay, well, let's use our angle. And this will be then the adjacent plane. Right, this will be the hypotenuse, right? So, I'm going to set that up. Circle. What trig ratio has adjacent and hypotenuse? So cosine of
So, in the unit circle, like,
equals
the power of 4.
X over 1, right? Which is really X.
Right, we're going to 2. So it is.
What's cosine of 2?
That's what happens.
Because of that.
That's diagonal.
So this is my closest triangle, right? So that means that one also.
45, 45.
Yeah. Okay, and then we have similar fashion to figure out this side and this side, right? Okay, I'll leave that to you. All right, how are we doing here, guys? Figure it out now, kind of? Nope. Okay. Got your hands? Yeah. Good. Yeah. Okay. So now find the area perimeter. Yeah. So the perimeter is easy, right? You gotta add them all up. Yeah. And remember, for the response question, you don't have to even find the term. You don't need to find a common denominator or anything. So we need to say this one. circle here. D1. And now for the area, I'll let you kind of think about that. I'll suggest this, Joey. Break it up into.
With just triangles.
Yeah. Find the two sides.
Yeah.
So, well, again, you see how this quadrilateral is really made up of two triangles, right? Okay, so, in fact, two right triangles. So we can talk about the existing sides of these right triangles, right? So, for example, this right triangle right here is a 45, 45, 90, right? So, pick one of your angles there, let's say the 45, and let's say we're going to find this side right here. Call it this. Okay. So we have, we want to find the adjacent leg, and we have the hypotenuse. So what trig ratio do we use that has adjacent leg?
What? You do the area. Yeah. I think it might be stretching the you don't have to finish the problem if all you have left is arithmetic rule, but yes, I got the area.
Did you get 2 times square root of 3 over 8?
Now I got square root of 2 over 2 squared divided by 2 plus sine of 30 times sine of 60 over 2.
When I'm doing like first semester, first semester.
Okay. Right. Okay, you just did like the unit circle thing. That's fine. That's okay. You can still use that, right? Because again, it's all related. It's all related. So,
Yeah, it is simplified. Well, not
Ryan, you just do.
Okay.
Base.
You got something back here? No, why not? Well, this is great. What time of 30? You know that?
You don't do base on Teddy.
Well, 1/2 base on 10.
That's for a triangle. For 2 triangles.
Yeah,
I
2
I found the area of both the triangles and added them together.
Yeah, by doing 1/2 base on type for each one.
The perimeter.
So I did.
What are these
I'm
rules?
giving them more values to you.
Area is one. This is one.
Angle, yeah.
Ryan, did you get these on both sides?
So obviously it can't be 30-60 now.
Yes.
How did you get that for your?
Oh, no. For my other two,
Oh, so you're,
for
well, so now hang on, sorry.
these two sides,
We need to pause real quick. So we, Anna also had the same thing too, so.
I got the
So this angle was 60.
sine of 30 and
That's
the sine of
30.
60.
So this angle is 30, that's correct.
Oh.
Then this angle has to be 60, right, because of the triangle. But
Austin,
now
did you get what I got?
This needs.
I don't know what you have.
Let's say which angle is equal. So this bottom triangle, the bottom kind of part, that's not.
I have the same thing for the perimeter. Area, I'm not done with the area yet, but I feel like I'm gonna get there.
I just had sine of 30 and sine of 60 for these two
So
angles.
this is gonna change your sine there, because now we're no longer thinking what's the cosine of sine of 30, it's sine of 45. They're just right there all out. Perimeter is root 2 over 2. So that means, again, we have, this is an exogenous triangle, right? So that means the other side of that triangle is going to be what?
What'd you have, Caleb, for area?
The same thing, right?
2 plus the square root of 3 over 8. Or it also means square root of 3 over 8 plus 1/4.
That's what I got.
And now by similar argument, you can figure out these two things right here, right?
I feel like
Alright, let me get my, my answer key over here. Alright, I did combine, into one fraction kind of dealio.
So you have 2 plus root 3 over 8.
I have 1/4 plus root 3 over 8, and then 2 plus root 3 over 8.
Okay, so it's which perimeter word do you have?
Root
3 plus 1 plus root 3, okay, so you have 2.
Wait, how do you... So for these two side angles,
Yeah. How do you
got-
find those?
Well, I sort of found them, I got sine of 30 or sine of 60 instead of...
What's sine of 30 though? We know that using our, well, right, we should know that
I
using
should
our
know
unit
that.
circle.
Oh, using our unit circle?
Right, what's sine of 30 degrees? We should know that, right?
Oh!
Sine of 60, what's that? We know that using our unit circle, right? That's why, so that's why I said we can do this on the calculator, because it's all unit circle. So, Caleb, let's see here. 2 plus root 3 over 8, and then, yeah, root 3 over 2, plus 1/2, and then 2 root 2 over 4. Yep. All right, Mac, how are you doing?
I didn't get it.
Good stuff?
Yeah.
King size? Okay, but you got the angles, maybe?
Yeah, I got it.
Well, okay, so let me see here.
Can I see your pencil real quick? Alright, so this arc is actually not where you mark for this here. So that's going to change. Exactly.
Oh, yeah. Yeah.
And that makes that angle. Okay, so, alright, now, let's try to break this up, right? We clearly see we have a triangle here, a right triangle here, and also a right triangle at, right? Okay, so let's focus on this first. So, let's say we want to find this. Okay, look at X. Alright, so now what trig ratio should we use? We can use that 45-degree angle, right? And what is this in relation to 45? Obviously, it's adjacent, great. And what's the 1? Okay, I don't know. So what trig ratio has adjacent to hypotenuse?
So bless you.
Bless you, yes, bless you. Cosine of F equals.
Yeah,
This is really a job, right? So what's cosine of 45? That is what you need to have down. So cosine of 45. So x is 1/4. Okay? Now guess what this side is? Well, it's also 45, 45. Yeah, exactly. Now by similar argument, you can kind of find those two using the 36. Okay? Yeah.
Christian, you okay?
I have no idea.
No idea. Okay, that looks good, that looks good, that looks good, that looks good. So yeah.
So is this like for areas?
So, oh, you're trying to find the area. Okay, gotcha. Okay, so this area formula will give you the area of that one, right? And then I guess this one is the area of that one, and then you just add them together. So you got 2 plus root 3 over 2. Yep. Or it should be over 8. Because when you multiply those denominators, it's 2, 2, 2, it's 8 in the denominator, and then 2, 2, 8 in the denominator. Alright.
Might be.
Great.
Might be.
How do you find the area of, yeah, so that's a quadrilateral, right? 4 sides. But, you don't have to find the area all at once, right? You find the area of pieces, and then add the pieces together.
Yeah.
Right? So, can you find the area of a piece? Right? The triangles, right?
So almost got it.
But here's the thing, Emma, now that you've seen it, it's going to be like, easy, doing my sleep.
Top of my life. Oh my gosh, this is what's the worst. The absolute, no, that's right. Yeah, that's right. Oh, we did it right. Yeah, that's right. It just took us a while. And that's okay. That happens sometimes, but you got it. That should be very rewarding.
Plus
Yes,
root 3 over.
Yeah, you can simplify it down. No, you made it. Wait, did you want to simplify it?
Nope, you don't need to.
Just, you don't need to go down to like.
Once you
No,
realize that it was like
if you had root 3 over 8 plus 1/4, that's acceptable.
But I can condense that even further.
You could, excuse me, you could, but you don't need to.
Okay. I did that. I did it so much.
Actually, it was like
8, because you're multiplying 2, you add them together like that.
we do break the rest.
And then,
I thought we had to, I thought we were nowhere. I thought we were gonna go back and say, what's the creek? And find on a 45 angle.
Please.
so root 2 times root 2
Tougher.
is 2. When you root 2 times root 2 there, it's just 2, not 2 root 3, right? It's root 2, yeah. Okay, whew.
So how fun was that, right? How fun was that? Okay, so I'm gonna. But here's so again, I don't believe it or not, I don't do this to torture you. But what I do it for is because I want us to get in the practice, right? So we as teachers are very good at like training you to do problems in very certain ways. And in fact, I think we, no offense, I think we like train helplessness in you in a way, where it's like we like, you know, like you see a problem and you've never seen this kind of problem before, and you're like, oh no, I've never seen this kind of problem before. What do I do? So I get stuck and I get frustrated and I give up and I stop sometimes, right? So I want to really try and kind of work in us the idea of like perseverance and just sometimes just trying things, okay? Believe it or not, you guys are like smart enough to figure things out on your own sometimes, okay? And so that's what I kind of want to have us practice. And the only way I can really do this practice is by making you uncomfortable by doing problems like this, okay? So we first of all realize, right, this quadrilateral is really made up, okay, in a very tricky fashion of two special right triangles, all right? And so when I told you no calculator here, it actually turned out to be very doable without a calculator because they were those special right triangles, okay? So, and it's, you know, I wrote it that way on purpose, right, because otherwise we wouldn't have been able to do it. All right, so anyway. These two sides here end up being root 2 over 2 and root 2 over 2, but based just because it's a special right triangle there. This one ends up being 1/2, and then root 3 over 2. Okay, and then your perimeter, okay, it's absolutely fine to just add up all four sides there. So you could have just said 1/2 plus root 2 over 2 plus root 2 over 2 plus, bless you, root 3 over 2. And you could have stopped right there. Done. Don't need to combine anything, because again, in a free response question, you would be done. Now, let's say this were multiple choice, though. There's a good chance this would not be your final answer for multiple choice. So you do need to be comfortable, you know, combining like terms and stuff like that here. So root 2 over 2 plus root 2 over 2 is 2 root 2 over 2. So I'm going to try, I think the most easy way to kind of simplify this is just put it all over one denominator. So basically it's going to be like 1 plus 2 root 2 plus root 3 all over 2. I think that would be the simplified version.
Does it matter what order you put the numbers in?
No, yeah, because addition, right, order doesn't matter for addition. You can do that, okay? And then area. All right, we have this oddly shaped quadrilateral, but that oddly shaped quadrilateral is made up of two what? Triangles. So we just do 1/2 base times height plus 1/2 base times height. Okay, and I'm just going to like dot this because it's a lot of writing, right? But it ends up being root 3 over 8 plus 2/8. I converted it to common denominator there. And so you get 2 plus root 3 over 8. But again, if this was a free response question, as soon as you plug in for B and for H and for B and for H there, you're done. Okay? So you don't need to simplify as long as it's all arithmetic. You do need to plug in, but as long as it's arithmetic, then you're done. So yeah, question.
Like for tests, I know you might know that area equals 1/2. That's like the first triangle and the second triangle. Would you have to do like a subset 1 and a subset 2?
I think you'd be okay. I think you'd be okay there. I think you would be okay. If you wanted to like break it up into 2 and then like put it together.
I had just like A equals 1/2, B subset 1, H subset 1.
Right.
Equal the triangle 1 and 2.
That's fine to do that. That'll be fine. I don't think it's necessary. I don't feel like I've ever came across that where it's like you had to do that. So I think it should be okay to not like have to do the subset stuff. If you want to though, for your own organization's sake, that's fine. You can. Okay. So there's that fun one. Okay. Good times had by all. So now we're going to take a look at a few more things. We're going to look at trig equations. Trig equations. All right. All right, so trig equations. Okay, when it comes to solving trig equations, when it comes to solving any equation, remember the idea is that we're trying to find all the values that work in the equation. The problem with trigonometry is that there could be an infinite number of solutions, which we don't have to worry about those. So instead, we normally solve trig equations from 0 to 2 pi, not including the 2 pi. Okay. So, our example here, we're asked to solve for theta, and we'll give the equation 2 sine of theta plus 1 equals 0. All right. So just like in any other equation, whenever we want to solve an equation, we want to get the variable by itself. So in order to do that here, what should be our first step? Subtract 1 from both sides. So you get 2 sine theta equals -1. And then divide by 2. So we get sine of theta equals -1/2. Okay? And so now we need to go back to think, using our trigonometry, now we're working backwards here. So we have to think, what values of theta, when you take the sine of it, do you get negative 1/2? Well, we can go back to our little reference triangle here. I'm going to draw that here real quick. So right angle, put the 2 there, the root 3 there, and the 1. Pi over 6, pi over 3. Okay, so let's not worry about positive or negatives right now. Let's just figure out, when does sine of theta equal 1/2? Well, let's see here. Sine is opposite of hypotenuse. So 1 over 2, right? 1 over 2 is what we would need. So what's the angle we're talking about here? The pi over 6's, because pi over 6 is opposite the hypotenuse there. Okay, so it's pi over 6's. But pi over 6 isn't the right answer because that's in the first quadrant and sine is positive there. We need to be negative 1/2. So what two quadrants do we need to look in? 3 and 4. So what is the pi over 6 angle in quadrant 3? 7 pi over 6, or 7/6 pi, however you want to say it there, yeah? Okay. And then what is the pi over 6 angle in quadrant 4? 11 pi over 6. You got it. And there are your answers. Okay?
Couldn't you just say, you have to use the radian value, not the degree value?
So, right, and especially here because it's we're kind of
yeah.
designated there. Yeah, we do want to use the radian measures. And again, I know we had just finished talking about degrees, and I was like, well, we'll use degrees here because that was the context given to us. But when you're kind of in the wild, you want to give answers in radians, not degrees. Yeah.
I'm going to make this up with a different part of trig, but for tangent, we still use 0 to 2 pi, or is it 0 to pi?
We will still consider from 0 to 2 pi. Yeah, the period is pi length. It repeats itself every pi instead of every 2 pi. But we still do concern ourselves with 0 to 2 pi.
Inverse trig would be negative pi.
Yeah. Sorry, negative pi over 2 pi. Yep, exactly. All right. And we don't have to worry. Thankfully, we don't have to worry too much about that kind of concern that you had there, Brandon. So yeah. All right, next one. Tangent squared of, that's an alpha, okay, a little fishy there. It's an alpha, right, for those of you, and it's probably not a very well-drawn alpha, but it is a little, okay. Tangent squared of alpha minus 1 equals 2. For some reason, in math, we like to use Greek letters to represent angles, right? Theta is a Greek letter, right? So maybe when you go to college and you join some frat or sorority, you might have theta, although I feel like mostly women's fraternities have theta? I don't know, actually. I don't know with Greek life. So anyway, you might have a theta in your name, right? You might have an alpha in your name. So this is a lowercase alpha, though. The uppercase alpha looks like an A, which is what you would more likely see in your name. Anyway, how do we solve this one? What do we do? Add 1 to both sides. So you get 3. All right, next. Square root. Ooh, messy. Okay. So tangent of alpha, let's see, square root. So we get just the tangent of alpha equals the square root of 3 then, yeah? Plus or minus, Christian, you got it, that's right. Very good. We took the square root here, right, in an equation context. So we need that plus or minus, all right? Because again, we're trying to find all the possible values here. Right? So when you take the square root in an equation, in the context of an equation, you need to have that plus or minus in there. Okay, great. So that kind of makes things a little bit easier, actually, when you have the plus or minus. You don't have to worry about what quadrant you're going to be in. It's all the quadrants. Okay? So, all right. What trig ratio? So let's see. Tangent is TOA, so opposite and adjacent. So we need this to be root 3 over 1, right? That would give us to it. So that is what measure there? Pi over 3. And it's all the pi over 3. So it's pi over 3. That's the first quadrant. What's the pi over 3 in the second quadrant? 2 pi over 3. And then 4 pi over 3 and 5 pi over 3. And that's it. Okay. Okay. I'm going to do one more, and then I'm going to have you guys do one, and we'll see if we have time. I think we should have time. We got this. Questions on that one? We're okay? No questions? All right, no questions. We're moving on. This is the final example, and I'll have you guys try one if we have time. I hope we have time. We should have time. We should have time. All right, 1/2 cosine squared theta minus cosine theta equals 0. Okay, so what we should do here is add cosine theta to each side, and then divide each side by cosine theta, and so we get 1 and 1/2 cosine theta over here, right? No, we shouldn't do that. No, and so, right, exactly. Mr. Meyer's like, when he speeds up and he starts like asking, like, right, we should do this, right? No, we don't want to do this. And the reason for that is the same reason why when you see something like this, x squared minus x equals 0, right, you never want to add the x over and then divide both sides by x, okay? You lose solutions when you do that. You lose solutions. What are we really supposed to do when we see this x squared minus x? Factor. Guess what? Factor. We factor out a cosine. Okay, because we'll lose solutions. And I'll show you how we lose a solution there. Or potentially lose solutions. In this case, I don't think we actually do, but we potentially lose solutions in this case. Well, actually, no, we do lose solutions. Yep. Okay, so now that I have two things that multiply to make 0, how can I break those up? Yeah, set both equal to 0. Can I break it up like that if it's equal to like 1 instead? Could I say like cosine theta equals 1, 1/2 cosine theta minus 1 equals 1? Can I break it up that way? No. Okay, remember, when you have two things that multiply to make 0, that is a very special situation. Very special, okay? Because if you know you have two things that multiply to make 0, that means one of those two things must be 0. But if you have two things that multiply together to make 1, for example, must one of those things be 1? No, right? Like, for example, 2 times 1/2 gives you 1. It doesn't have to be 1. But if two things multiply to make 0, one of those two things must be 0. So that's why we can use this. It's called the zero product property. All right. When does cosine of theta equal 0?
Pi over 2.
Pi over 2 and 3 pi over 2. Right. We have to remember those, right? There's no fancy reference triangle to use for that. Good. We have a little bit more work to do here for this one. We have to add 1 to both sides. Multiply both sides by 2. Okay. And when does cosine of theta equal 2? Never. So there are no solutions on that branch. Okay.
No.
Here, right, if we had done it the wrong way, like Mr. Widmeyer, suggested to you subliminally, or not subliminally, but like subconsciously, or whatever you want to say, I don't know. The one I kind of like went to real quick, right? I multiply by 2, we'd end up with just this, and we would have lost these two solutions, right? Those solutions aren't going to be part of this way, so that you can see why this is a bad idea. Do not do it. Okay? So bad. All right, so I don't have enough time for us to get through this last one here. I know you guys are really disappointed, but hopefully there won't be anything crazy on the homework that'll be like it.
Oh, no, I have one.
Yeah, me too. I was going to ask you how
Okay,
to put mine.
your assignment is page A49, numbers 27 to 39 on.
That was a good idea. I have to finish reading and flexing.
So try not to stretch yourself out too much there with those.
I'm going to be able to answer who.
7 problems. How many parts? I think 27 has A through Z. 29 goes A through double Z, I think, and then, yeah, well, you can figure out the rest.